Hi, today we will see this topic detect cycle in undirected graph. So all the questions which I have discussed is based on importance. Like the one I discussed in the beginning is the most important one, and then the second one was second most important one. So I believe this detect cycle in graph is the most important topic of graph. So let's see. So what is cycle? So it is easy, right? Here you can see circular path. It is cycle. Here you cannot see any circular path, that is, so here we don't have cycle. Now let's see the input, because understanding input is important. What is meaning of 1 and 0 for 2 and 1 3? It is little bit confusing because it's written like this. So it means that this is a 2D list, right? And every element is having an index. So 1 is having index 0, 0 to 4 is having index 1, 1 3 is having index 2, then this is having index 3, and this is having index 4. So let's start again. Index 0, 1 comes on index 0, which means that there is a path between 0 and 1. Okay, these three elements come at index 1, which means there is a path from 1 to 0, which is obvious, 1 to 0. There is a path from 1 to 2, which is obvious, 1 to 2. And there is a path from 1 to 4, so 1 to 4. This is index 2, so there is a path from 2 to 1, which is correct. There is a path from 2 to 3, which is correct. This is at index 3, so there is a path from 3 to 2. There is a path from 3 to 4, which is correct. Similarly, like that, things happen. Let me show you another input. There is a run compilation. ChatGPT solution is considered to be the best solution. That is why I will discuss this one. See, here 5 means there is 5 input. They have explained what they are. V and E. So it means we have 5 vertex and 5 edges. I knew this, I just wanted to show. So 5 vertex, 5 edge. So what is vertex? Like these all nodes are vertex. Like 0 is one vertex, 1 is one vertex, 2 is one vertex. What is edge? So from 0 to 1 there is a line, that is edge. So there is total of 5 dots, 5 nodes, 1 2 3 4. That is why we have 5 vertex. There is 5 edge, 1 2 3 4 5. That is why we have E is equal to 5. Now see, 0 1, which means there is a path from 0 to 1. 1 2 means there is a path from 1 to 2. 1 4 means there is a path from 1 to 4. 2 3 means there is a path from 2 to 3. Let's confirm, 2 to 3 there is a path. Now 2 to 1 should also be there. So notice this, that there is a path from 2 to 3 and there is a path from 2 to 1 also. I mean, they have not mentioned it in here. Now I am guessing that internally they do it like this. So if they find a path from 1 to 2, so they add edges as 1 to 2 and 2 to 1. Here you can see this adding edges function is there. So if there is a path from 1 to 2, then they will add like there is a path from 1 to 2, u is 1, v is 2, and then they will also add 2 to 1, so v is 2 and u is 1. So that's how the driver code is working behind the scene. So I like wasted so much time in explaining input. Now video will get longer and I don't like that. Alright, so but that was important. If you will understand input now, it will help you a lot. Anyway, that's why they have given two different type of inputs, like here something like this, there something like that. So let's see how to solve this. So this will be the function we will be calling first, and this is the helper function, which means this below function will call this function every time it find a need for it. So let's see let's discuss the algorithm first. From 0 to 1, how we will find the cycle. So the funda is like something like this. You start from 0 and you mark it as -1 for parent. Like you are starting from 0, so you are not coming from anywhere, right? You're not coming from anywhere, so that is why the parent of 0 is -1. But when you will go to 1, who will be the parent of 1? 0, right? Because you came from 0, so only 0 is having the parent of -1, because you are literally starting from here. So that is why here in this line you can see, okay, I will start from here, don't focus here, focus here. From 0 we will start, we will go to 1 and then check if we have visited 1 or not, or never or not. Okay, let's start from start. We start from 0 and mark it true, which means we have visited it. We go to 1, then mark it true, okay, which means we have visited 1. Now when we go to 1, we try to go to all its neighbors, but how we go all its neighbor is in DFS format. So it's not like we will go to 0, 4 and 2, which is BFS. It's like we will go to where 0, and then because 0 is having -1, which means it is parent and we won't be visiting here, so we will go to any next. I think it will be 2 because 2 is smaller, so we will go to 2, and then again we from 2 we go to like 1 and 3. So 1 is parents, we won't be going there. We'll go 3 and then 3 to 4 and 4 to 1, and then here we have already visited, so it will return us true. Something like that it happens. All right, let's discuss the code. So we will mark visited is equal to false. So what it means is that it will create like 1D array list, number of vertices is 5, so it will create false 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 5 times, which means we have not visited it yet. One thing you can notice, we are not checking Okay, so in this line what we are trying to do, we are visiting all the vertices one by one. We will check if 0 is causing any cycle, then if 1 is causing any cycle, 2 3 4, that is it. It makes sense, like we have to check for all, check the if condition, but there is not a else condition. So you can like mm, make a note of it, that we are only doing something if it is not visited. So if visited is equal to false, which means we have not checked that node for cycle, so we will check it. Here what is happening is that we are calling a helper function cycle util, so it will help us detect the cycle. I visited -1, so why we have given I and visited and -1? So we have given visited because we want the helper function to know which node we have visited or which node we have not visited, so that's why we are giving visited. Why are we giving I? So you see, I was 0, right? Initially 0, so we want to check if 0 is creating any circle or not. That is why we are giving here 0. Why we are giving -1? Because this will happen only one time, like only 0 will be having -1 as its parent, because 0 has no parent. That is, so if this function returns true, which means if it is visited, then we will return true, which means we have already visited it. So the reason for that could be that there was cycle, that is why we return true or else false. Let's see how this function works. So see, it is taking the node which we have to like check, which was 0, and then visited array and then parent array. So parent, it is just a node -1 because it has no parent, because we are checking it, so we have marked it as true. Makes sense, like we already started checking it, so we have visited it technically, so we have marked it as true. Now what we are trying to do is that we are checking all the neighbors of I. So I is 0, so what are all the neighbors of I? Only 1 is there now, so we will, so what will be I will be 1. Now let's see this line for another node. Okay, what if v was 1? If v was 1, then what could be the value of I? If v was 1, then value of I could have been 0, 4, 2. Okay, if v was 2, then what could have been the value of 1? I mean I. If v was 2, then value of I could have been 1, 3. Now here notice very important thing. Let's suppose v was 1, which means this node, then a value of I could be 0, 4, 2. But we don't want to check 0, because from 0 we came to 1, so 0 is literally parent. So what we will do is that here we have a condition that if it is not equal to I, if parent is not equal to I, then return to Wait a minute, just all right. So we are trying to understand all the if and else cases. That one thing is sure that we will check for all the adjacent nodes, right, of parent. So we is the parent. So suppose if v is 1, we will check for 0 for 2. So there is if and there is else if. So just consider b instead of else if, think it as if parent is not equal to I and visited is equal to true, because that's when it will come here, right? So if it is already visited and it is not a parent element, okay, then we will return true. Because see, from if we go from 1 to 0, then 0 is visited, right? But 0 is also a parent element, and in that case if we will return true, then that is incorrect, right? It doesn't make sense, because from 0 to 1 and 1 to 0 there is no cycle. So that is why we have added a statement that else if parent is not equal to I. Or it should have been written that I is not equal to parent, but both are same. All right. So in that condition should have been above, but all right. Here if condition is there. So if it is not visited, then we should check if it is creating any cycle or not. So we will call this function is cyclic util, and we will send I, and what will be parent this time? V, right? Because I is like neighbor of V, so the parent for I will be V, right? And if so, what this will do is it will create a copy of this function and check it. So if that returns true, which means we have visited it. So and if we have visited it, then it will return true. Else if both conditions fail, then it will return false, which means we have never ever once visited any node. So one thing which I want to say is that it is actually difficult to visualize without tracing on pen or paper, but it actually pass the value, okay, to the calling function, which means it will return true to the calling function of this helper, and it will return true to the calling function of this helper, then again. So like if it go from 0 1 2 4 and then 1, okay, so it found cycle. So what it will do, that 1 will give true to 4, then it will give true to 3, it will give true to 2, it will give true to 1, and then it will give true to 0. So that's how basically this whole recursion works. I know it is little bit difficult to understand, because without tracing it on pen and paper, it's actually very confusing. So, but it is also very easy because the number of line of code is less, and if you like get the hang of it, right, then it is like really useful in lot of the graph question. A lot of graph question uses this concept.
All right.